Hello and welcome to another virtual jug session, our second in April, and it gives me great pleasure again to welcome back one of our top speakers from 2014, Mr. Josh Long. How are you, Josh?
Hey, how are you? Doing good, thanks. Thanks for
Good,
having me
thanks.
back.
And last time we spoke to you, it was San Francisco. This time you're not too far away from myself, actually, in just across the water, right?
Yep, just across the pond.
A smaller body of water this time. You're in Devox, Paris, right?
Yep, Devox, France.
And
Great community.
you're doing the typical rock star traveler thing and doing a session from a hotel in on your travels, right?
Yes, sir. I'm grateful for the opportunity.
So it's absolute pleasure to have you back. And today you're going to be talking about this little known fad called microservices. Sorry, this wonderful new architecture we're building up called microservices, right?
I've heard things. I'll bet it's gonna be big one day. This
Awesome.
thing.
Awesome. So we look forward to that. And Mr. Oleg, how are you doing, sir?
Hi
Well,
Simon, I'm really well. Looking forward to the session.
And how's our survey going on Rebel Labs today?
The survey is going pretty well, so we are collecting responses about Java application performance and Java profilers, and we at Rebel Labs we are doing that yearly. So this year we chose the topic of performance because it's really interesting and it actually touches like everyone in the development community. So we'll give you a link if you haven't done yet. Fill the survey. It just takes literally minutes. And share that, and we will provide you with a beautifully looking report somewhere late May based on the results.
Awesome. And if you want to just make sure, if you want to put that in IRC and just make sure that everyone is accessing the session correctly, I will just show you my screen and show what we're doing today. So this is going to be building Bootiful microservices with Spring, and this is going to include Spring Boot, of course, and Spring Cloud as well, which is going to be interesting. Our speaker today is Josh Long, our second time speaker, in fact, with the Virtual Jug. And you can follow Josh on Twitter. You can be his 1 millionth follower at Starbucks Man. I believe he's big into coffee.
I am.
Yeah.
I'm also kind of a big, web scale kind of guy.
All right. Okay. So yeah, well worth following Josh on Twitter. As normal, I'll mention that the Virtual Jug is sponsored by Zero Turnaround, and we have our media partner with Rebel Labs. And Rebel Labs will be doing an interview with Josh straight after this session. A little bit about what Zero Turnaround do. We have a couple of products, JRebel and XRebel. JRebel allows you to reload your code changes instantly, so make your code changes in your IDE and see them reloaded instantly in your runtime. We also have XRebel, which is a lightweight Java profiler, which allows you to profile your web app code during development. And XRebel version 2.0 was just released yesterday, so do check that out. There's a 14-day free trial for both of them. But for now, I'll just let's ask Oleg if everything's okay on...
It seems okay. I can access the video. If you cannot access the video yet, you should refresh.
You're telling people who can't watch the video how they can watch the video, Oleg.
That's a good point. I'll drop that in RC.
And one thing I will mention for those of you who are watching the video is if you wanted to interact with us, you can talk to us on Freenode. Almost said FreeCycle then. You can interact with us on Freenode at hash or pound virtual jug. And if you're watching on virtualjug.com, the IRC is right next to the YouTube embed there as well, so you can connect very easily there. If you ask, you can have loads of discussion there. If you want to ask Josh any questions, do so in the IRC chat, and I will ask him on the Hangout. So I don't think there's any further ado. So let's move over to Josh. And Josh, tell us about microservices.
Well, thank you very much, Simon. Thank you for having me yet again on this amazing venue, the VJug. I'm going to share my screen here. Entire screen. Okay. There's Oleg. Can you guys see a picture of Oleg?
I can.
Oh, we can. Okay. So, as Simon so ably pointed out, my name is Josh Long. I'm the developer advocate for the Spring technologies at Pivotal, and I'll be showing you guys some code today. The code you can find on that I should have bit.ly that URL. It is 2015. I owe you guys better, but go to my GitHub repository, Josh Long, and you'll find a microservices workshop thing in there. You know, Twitter handle, email, I am at your service forever and ever. So if you need anything, don't hesitate to reach out to me. I'm going to hide this now. Whoa, where'd that go? No? Okay. I'm a contributor to many different open source projects, not the least of which, of course, are Spring Boot and Spring Integration. Author of 3 different videos on Spring. Not the latest and greatest is on Spring Boot and Cloud and Microservices, and I'm the author of 5 different books. Also, this one's from O'Reilly, and this one is also on Boot, Cloud, and Microservices, and Cloud Foundry for both of them. So that's that. I work for a company called Pivotal. We started Pivotal in 2013. It's a new adventure, a new horizon, and a big part of what we're trying to do is to build sort of a platform and technologies that serve modern developer workloads, modern developer use cases. And a huge part of that is, of course, building applications that work well in the cloud, and a huge part of that is building applications that run well in the cloud. And of course, we have a cloud. So if you know about Pivotal, you know about you may not know about Pivotal, but you may know about a lot of our different technologies. We've got Redis, the distributed data structure server. That's pretty good. It's used by some small mom-and-pop shops like Twitter and everything. Cloud Foundry is the open source platform as a service. Good stuff. Used by also some small mom-and-pop shops like IBM and HP base their distributions of a platform as a service on Cloud Foundry, for example. We have Apache Tomcat leadership in the house. We've got RabbitMQ, that is the most widely used message queue in the cloud. We've got lots of good stuff, and of course, notably, Spring. So we have a lot of great technologies geared for building big systems and big distributed systems that work well. And we've spent a lot of time sort of thinking about that use case. And of course, one thing we're seeing a lot of customers moving to is this idea of a microservice. Well, first of all, they're moving to this idea of a cloud-native application, right? Netflix described this before. They talked about the cloud-native architecture. There's 2 parts to that. There's microservices and there's NoSQL, both of which allowed them to build apps that scaled and were easy to manage inside of a cloud environment. Today, we're going to talk about the microservice, right? When we talk about microservices, it's important to remember that it's not really a new debate, right? This is not a new discussion. You'd be forgiven for thinking that some of these ideas are fairly old. This is a email from Ken Thompson, one of the Unix luminaries from back in 1992, one of the original flame wars, on the net. Now, of course, we live in a much more civilized, sophisticated time. Nobody on Reddit ever says anything bad to anybody else. It's always very polite. I'm sure you'll agree. This email is between this thread is going on between Andrew Tannenbaum, then a professor, and Linus Torvalds, of course, the progenitor of Linux, the operating system. And the debate is about whether Linux is appropriately designed, right? And the contention that Andrew Tannenbaum is trying to make is that Linux, while it may run and while it may have been very fast to get working, represents an anti-pattern. It represents something that is sort of an evolutionary dead end. And Linus is saying, well, it's fast, it works on all this hardware, it's boss sauce. And then Ken Thompson chimes in and says that he generally agrees that microkernels are probably the wave of the future. However, it is, in his opinion, easier to implement a monolithic kernel. It's also easier for it to turn into a mess in a hurry as it's modified. And I think that is super prescient. I think if you take microkernels and replace it with microservices and take monolithic kernel and replace it with a monolithic application, you get the same argument. You get the same point. It's a very valid point. Yes, of course, building a monolithic application, something that is something where the web app and the services and all that are co-located in one giant deployable unit. Of course, that's easier. We all start that way. There's nothing particularly wrong with that. And it is easier to evolve. I mean, if you're starting a brand new app today, are you going to sit there and imagine 10 different moving parts, or are you going to imagine just one? Hopefully, the scope is small enough that you imagine just one. And if your scope becomes bigger, then of course it starts to become problematic to have all that stuff co-located in a giant, singly linked sort of a monolithic application. So there's nothing wrong. I mean, it's natural that you would start that way. However, as we move forward, you'll see that there are use cases that we invariably all have to confront these days that are better served by microservices. The astute reader will, of course, note that Linux did eventually end up being the one that dominated, not Windows NT, not OS2 Warp and all that. And of course, that's a great point, right? The monolithic kernel did actually become the winner in this case. But I would argue that that's actually the exception that proves the rule. It's the one place where having inter-process speed is paramount, right? It's the one place where you can afford to have a fat, and by that I use air quotes if you can see it. It's one place where you can have a fat monolithic application, or monolithic kernel in this case. Everything else, even one level above in the operating system, looks more like microservices, right? Even the command line utilities. Imagine doing apt-get install for a utility on your Debian or Ubuntu instance and having to reinstall the operating system, right? That wouldn't scale at all. It's terrible. Imagine if every utility on the operating system was written in the same language as the kernel itself. Again, terrible. It wouldn't be tenable, right? So, what do I mean by use cases, and what do I mean by this exodus to microservices? Well, the old architecture is broken for a lot of people, right? I'm not the only one to say. In fact, I'm sitting here before you today. I'm late to the game, right? This is not a new discussion. Again, Twitter, the likes of Twitter, Facebook, Netflix, Google, eBay, all of these large companies, in order to meet the challenges of their kind of scale, had to move from this monolithic architecture to something that looks like a microservice architecture. And these are famous, I think, fairly famous use cases, right? Twitter, Amazon, Netflix, eBay, Facebook, all of them have very, very well documented stories about how they had to make that move. For a lot of us, there are different reasons why we make that move. A lot of us tend to think in terms of scale, and certainly when I think about scale, I think about two different things. There's technological scale. How can I make my application grow and handle more capacity? And how can I make my team, my business scale, right? This one's pretty obvious. Moore's Law. It's been fairly well known for the last 15 years or so that Moore's Law is kind of abated. The free ride that we were enjoying before doesn't apply anymore, right? It's much easier to scale out, be it by threading or processes than it is to scale up. Pretty natural, pretty I think self-explanatory. Computing power has not gotten much faster per core. It's gotten faster by adding more, right? More capacity. We have more data than ever, right? And this is a big deal. This is a big part of the sort of move to be able to handle more scale, is that data is now everywhere. It's in the veins of everything we build today. And so I like this number. It's big enough that it deserved a big font. That's how big it is. It's crazy amounts of data being created these days. And this is, again, everything you're talking about here, these are not problems that we had 10, 15 years ago, right? These are not use cases that we had 10, 15 years ago. We have more mobile clients than ever. I think actually even this is irrelevant. This number is 2012, I think, 2013. But we're seeing, for example, in the Android use world, 1.5 million new activations every day. That's crazy. Or that's just a lot of new clients and a lot of new opportunity for your applications and a lot of new users. Of course, some of them are now becoming repeat activations, but still, the growth is impressive. And if you're not aware of that use case, then your application won't succeed, right? Mobile. I mean, mobile is certainly one driver of scale. It's certainly one driver of people moving to this use case. But social, I think, is just as big, right? This is from 2012. This is a social world in 60 seconds. This is the amount of activity, the amount of sort of volume that each of these big social networks or services is accommodating every 60 seconds, right? I mean, again, 2012, so these numbers are out of date. The Internet of Things, right? This is this idea that everything has an IP address nowadays, and everything can be connected. This isn't theory. You can actually go out and buy a refrigerator now that will buy and trade its own power on the commodities market. This is really cool. I mean, there's things you can do now that you didn't even think about 10 years ago, because processing capacity is cheap and it's powerful enough. We talk about building mobile applications, but really a mobile application today, that doesn't need to be, that's not hamstrung at all. I mean, your average Android device or your average iPhone is a supercomputer by some standards from 20 years ago. So we have more devices than ever. And of course, I don't mean to be glib. Obviously, when we talk about Earth's population, we have some 7.2 billion people. There's an estimate that some 3 billion of us are connected. So the numbers are more like, it's more like we've got many devices per person, in our satellite world. Not that every one of us has a device yet. But IPv6 is certainly important in that move, right? We have this need to be able to accommodate more IPs, and we've officially exhausted IPv4. So we're seeing a lot of things, a lot of different things get connected to the internet. A lot of things have a demand to be able to call a service, call home and get connected to a service. These are technical reasons. I think the most important reason that people are moving to microservices, of course, is this idea of Conway's Law. It's stated as such, organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. This is Melvin Conway. I've heard it alternatively stated as a team that is building a compiler that is being built by 4 different teams will invariably be a 4-pass compiler. This is the idea that your software should reflect the business verticals in your business. If you imagine Amazon, for example, Amazon, the bookseller, they have different use cases. They have different goals. Different parts of the organization do different things, and they have to move their own velocity, their own speed. And same thing for Netflix, for example. Different services serve different use cases, and those services need to evolve at a different pace. So there's leadership, executive and business leadership. There's product management and project management and development and operations, all co-located in single teams. And that is a good thing, because it means that team can move at its own velocity. They're not waiting or synchronizing or waiting for chatter between organizations. Wherever possible, they try to avoid that, right? And so you end up with these small sort of singly focused services. This is an organizational change as much as it is a technology change. The benefit is increased for business agility. It's this ability to react to the marketplace and move quicker. This is, for example, one of the things that Netflix quite often talks about. So we've got, I think, with that boring intro out of the way, I think we can all agree that microservices are certainly where people are going. It's this idea that we have small, singly focused services. We've encapsulated things that will change from each other, and we've made it so that as small a team as possible can work on those services. This gives you a lot of benefits, of course. Like I said, you can react to the marketplace faster. You can make changes as quickly as possible without having to synchronize or have so-called flag day upgrades. You can use the right technology stack for the job. For example, you can build a one service. I of course am an idealist. I hope that every service you build will be in Spring. But in theory, just like the idea of a Windows mobile phone, it's a theory, not proven. There's nobody who's ever seen it yet. In theory, you could have built something in some other technology. I'm not saying it happens. I'm just saying it could. So that is, in theory, one benefit, right? You might have to integrate with other services, other languages. Polyglot is a thing. And if you expose services through the API contract, you get that benefit as well. That decoupling also lets you choose the right technology stack for the job as well, right? So if I decide that my service is better suited by having a full-text search engine, and this other service is better suited by having a graph database, and this other one by something like Cassandra or MongoDB or whatever, that's their prerogative. Each team can move and adapt as they need to without having to sort of get consensus from other teammates and other business stakeholders. Again, this is a very, very often mentioned scale cube. This is from the Art of Scaling software. This is my friend Chris Richardson, who's kind of a microservice aficionado. He introduced me to this great book called The Art of Scaling Software, and there's this great scale cube in here, and it describes 3 different axes by which you can scale services. And the y-axis is, of course, functional decomposition or microservices. The x-axis is horizontal duplication, whereby you just scale out, literally just adding more nodes. And then z-axis, of course, is data store scale, right? So sharding or whatever you want, right? So, and if you move towards the back and towards the top, you get something that is more scalable. So I'm not saying that microservices are the complete picture. You should certainly investigate things like NoSQL. You should certainly investigate things like a cloud that'll make it easier to scale out your services using horizontal duplication as well. But for our purposes, let's look at what it means to scale out software, what it means to tease apart a monolithic application and get them working. We all agree that moving to this architecture is valuable. There are some specifics to understand when you move to this microservice architecture. Here's some common points. I'm not really, these are just guidelines. I hope you'll consider them. These are the things I've drawn from different organizations and different studies. One is this idea of APIs, of course. Amazon has famously said that all different services in the organization should be fronted by a service. So, for example, 2 different teams shall never communicate via a backend database. The idea that an API should be discoverable and it should be easy to stand up is crucial. It should be friction-free, right? I should be able to go to production as quickly as possible. I should be able to discover what that API is doing as readily and as quickly as possible. So hypermedia, this idea of hypertext as engine of application state, proves very, very beneficial here. Independent deployability is also a very, very nice quality. It's not by any stretch. I'm thinking of one particular pundit in particular. It's not by any stretch what microservices is about. It's not the most important thing. It just happens to be very, very nice. It's this idea that I can isolate dependencies by deploying them independently. Okay, so let's look at quickly what it means to build a single service. I won't spend too long with this. I just want to establish that we can easily build a service today. It's very easy to stand up an API. It's very easy to get it to be production ready. If I was lucky enough to have you join the audience for the last VJUG session I did, then you'll know about Spring Boot already. So this is just kind of a rehash, just for those of us who haven't seen it yet. What I want to establish is that building a service today does not need to be painful. It can be very, very, very easy. And because it can be so easy, you should feel no hesitation in building as many of them as you need. That's the whole point, right? So I'm going to actually build a simple REST API here. Greetings, REST controller. Okay, I'm going to be using the Spring Boot CLI. We're going to be using Spring Boot. There's a lot of different ways to start with Spring Boot, of course. You can go to start.spring.io, like so, and then pick the pieces you'd like to use, and then hit generate, and you'll get a zip file, which should have you off and working in no time. So I'm going to say hello, hi, path variable, string name, okay, greetings. Now, okay, it's like so. I'm going to save it to my desktop, hi.groovy. I'm using the Groovy language here, but pick your poison. Okay, add request mapping. Hi. Name, okay, good. I'm going to hit save, go to the command line. Spring run. Oops, I'm going to add one more thing. I want to add monitoring facilities, right? So I want to be able to see what this application is doing at for runtime. I'm going to use Groovy's grab annotation, which is sort of like a runtime equivalent to Maven or Gradle, and it's going to dynamically pull down the jar that can unambiguously qualify as org Spring Framework boot : Spring Boot Starter Actuator. So this is the artifact ID in effect. I can also provide the group ID in the version, but as I can unambiguously discover this by using the Spring Boot Starter Actuator, I'll get the right result anyway. Okay, so Spring run hi.groovy. Okay, that'll look at my code. It's using Groovy AST transform, so it'll see that I've got types like the REST controller, and it knows that it can find that type by transitively importing the Spring Boot Starter web, for example. So I can then go to my local host machine like so, and vjug, voila, and I get the this little REST service. Okay. Now I can go to metrics, and I can see what the application is doing. Here, let me open up a pretty printing plugin. Localhost 8080 hi vjug. Okay. There's that. Metrics. There's this. I can see, how many requests have been made, how much RAM and so on I've got. I can go to env. I can go to beans. Importantly, I can go to config props, right? So these properties tell me the things that Spring Boot and Spring Cloud will respond to. Whatever libraries on the class path that Spring Boot is aware of, they expose certain configuration properties. And those properties you can configure in any manner of different ways. So for example, if I wanted to change the server port, I could say server.port. Okay, so let's do that. I'm going to go back to the command line, and I'm actually going to create a jar here called hi.jar. Okay, and that'll give me a jar that I can just throw into any kind of cloud service, and I can run the application like this, java-jar. But I want to change certain things about my application, so I can say java-jar server.port equals 8000. Okay, and then I'm going to say -jar hi.jar, and that'll start the application up. But I'm overriding the defaults. I'm overriding the defaults that are perhaps compiled into my application or that are just provided by boot already. So this is no longer here, right? If I go to 8080, that doesn't work, but 8000 should work, right? Or not. Localhost. What did I say for my jar? Yeah, 8000. Hi vjug. Voila. So there it is there. And that is to say that I can override a lot of different things using the config props endpoint and -d arguments. I could also do it another way. I could say export server_port equals 8002, for example. So java-jar hi.jar. This is an operations friendliness thing, right? So now this application is up and running, so etc. So that's all I wanted to show you about that. If you understand that, then you know it's dead simple to get an application up and running as a jar. You can, of course, use a .war as well, but again, it is 2015, so I'm a big believer in make jar, not war. Okay. Now, once we agree that it's easy to build a service, it's easy to get it up and running, let's take a look at Spring Cloud and what it lets you do to simplify the interactions between these services, because that, as I say, are where the details lay, and as you know, the devil is in exactly that. So I've got some code here, the Bootiful Microservices code, and I'm going to show you by way of Spring Cloud how to solve different kinds of problems, specifically related to scaling out, this sort of deluge of different services. As you add more services, you introduce complexity. This is precisely the problem that Netflix had. They have 600 different microservices, and these services depend on each other. So you create this long, fragile chain of services that depend on each other. And the benefit, of course, is that you should be able to manage these and scale these consistently if you have a good DevOps culture, or if you have something like a cloud, like a platform as a service to manage it. But there's still some fragility between services, right? So we're very keen on finding ways to solve it. Netflix have solved it. Google, of course, have solved it. eBay have solved it. And they've built a suite of components that they can use to sort of build software that is tolerant to failure, right? I mean, if you're thinking about your typical service chain, you have the SLAs. Well, of course, if my service demands 5 nines and the service I depend on only has 4 nines of availability, of course I am by definition, no better than that SLA. Instead, and of course Netflix with their 600 something microservices knew this. They knew that they couldn't afford to imagine a world where every service is highly available to 5 nines or whatever like that. Instead, they found ways to reduce the fragility so that service outages, which are invariable, they're ineluctable, they will happen, they found ways to mitigate those, right? So what we're going to do here is we're going to build 2 different microservices, contact service and bookmark service, and we're going to also look at a third service called passport service. These 2 services are going to, the first 2 services are going to expose very, very sort of boring, you know, I don't even care. One manages bookmarks, the other one manages contacts. And the passport service is going to be the client. It's going to be an API gateway to those 2 different services. And we'll see how through the use of centralized configuration and through the use of a service registry, we can simplify these interactions. And we'll also look at a few other things that Spring Cloud brings to make it easier to build services and consume them. Now, Spring Cloud is a set of APIs that integrates a lot of the Netflix OSS stack. It also integrates Spring Security OAuth for a single sign-on based on OAuth's experience. It also integrates Zookeeper and Console and just a slew of other pieces that we've discovered are really, really powerful for building stable, production-ready microservices. So the first use case we're going to go after here, and again, I've got kind of a skeletal directory structure here. We're going to go ahead and piece together an application, but I'm not going to go into the code for every little piece as we don't have enough time. So the first thing I'm going to do is I'm going to bring in a pom.xml here, okay? And our pom.xml is we're building here a configuration service, right? If you think about centralized configuration, like what I showed you in the command line here, -d or application.properties or application.yaml or environment variables, this works fine, but it gets a little tedious as you start adding more services. And there are a few use cases where it doesn't really provide the greatest solution. If I want to have centralized configuration and I want to know who made changes to what, it doesn't quite work. And if I want to use, for example, encrypted passwords, credentials, and I want to decrypt them live, perhaps via some sort of key, again, that use case isn't very well served by having things as environment variables. Plus, I don't have a journal. I can't see who made changes when and what changes those were, and then trace the resulting damage or impact in production, right? So all of these use cases sort of demand something bigger and better. For that, we have the configuration server. Okay, so I'm going to add a package here, source main Java, and then another one called demo, and I will make this a Maven module. Okay, and we import this. These are all Spring Boot applications. So again, we're just going to layer functionality. So configuration application, okay. And I'll get rid of that, Command J, vm config Java. There we go. The code is fairly straightforward. It's a Spring Boot application, and it's got public static void main, and more importantly, we've got @enable config server, okay. The config server is going to act as a proxy to some sort of centralized journaled configuration repository. In our case, this will be based on Git, right? It turns out that Git is actually quite good at managing history and so on. So we'll say that we need a bootstrap.yaml. This is a Spring Cloud-ism. This identifies the things that Spring Cloud microservices need in order to do their work. It gets invoked or gets used before Spring Boot's traditional application.yaml or application.properties, right? So it can be bootstrap.yaml or bootstrap.properties, but suffice it to say, Spring Cloud needs a way of identifying each service, and you do so by specifying a Spring application name, spring.application.name, using a property file. Then we're going to specify a application file here. So I'm going to say configuration application, and I'm saying that I'm going to run my config server on port 88888, and I'm telling it to use the Git repository that I've got in my local file system in my home directory, located here. Now again, if you had this code in the jar and then you overrode it with a -d argument, -d spring.cloud config server git URI equals, you could point it to GitHub, which can be locked down, of course, or you can point it to some other repository. So you can get something that works in the cloud as well as on your local machine easily. Don't even have to use profiles in this case. Okay, so we've got that. Let's confirm it's working. Up and away. Okay. So that is on port 8888. Localhost 8888, and I'm going to say bookmark service master, right? And that'll give me the JSON for the config service here, for the config file for the bookmark service. And you can see I've got this file to my local repository. It's managed by Git. I've got 3 properties: Spring, JPA, generate DDL is true, a message, and a mask. And then I've got 4 properties here. And these are in application.yaml or application.properties. Each service that connects to the config server will identify itself via its spring.application.name. In this case, the spring.application.name will be bookmark service. So it'll get all the configuration from the bookmark-service YAML file. It'll also get, as a fall-through, all the configuration from application.yaml. So all services will get application.yaml or application.properties, but only the bookmark service will get bookmark-service.yaml. This is just a convenience, right? So if you want to put common things, somewhere, put them in application.asterisk. Okay. Now we'll come back to this. The next thing we need is a Eureka service registry. Okay. A service registry gives you it's sort of like a phone book for the cloud. It gives you a place to store information about the topology of your cluster, about the topology of your service makeup, right? Here, I'm gonna, let's see, we want Eureka. Here, I'm gonna use the Spring Cloud Config client because I want my service to get its configuration from the config server. And I'm gonna use the Spring Cloud Starter Eureka server to stand up an instance of Netflix's Eureka service registry. There are other options, of course. Right now, I'm only using Eureka. You can act as a client to Eureka, to Zookeeper, and to Consul, right? But Eureka is nice because we can actually stand it up in Java, whereas the other two are different languages. Okay, so source main Java demo, good, and Maven re-import. Okay, and I'll add a Eureka application, and do that. VM Eureka Java. Okay. And what we have here is same as before, Spring Boot application. It's public static void main, and I'm printing out a message from the command on the command line. This is a Lambda in Java 8. It's an interface in Spring Boot command line runner, and the implementation is very simple. Void run. It gives you the public static void main string argument array. That's what I see here, and I'm just telling Spring to run this code when the application starts up, and to inject a configuration value from a configuration property file or an environment variable, or in this case, from our config server called message. Okay. So we'll see that. Let's go ahead and start this thing up now. Do I need anything else? Bootstrap. Oh, we do need to identify it, right? So Eureka Bootstrap. There we go. Eureka Service is the name. I'm telling it to consume configuration from the config server, which lives either at the URL that it can derive by dereferencing the value from this environment variable, vcap.services.configurationservice.credentials.uri. This is a Cloud Foundry environment traversal. Or I'm defaulting to this localhost :8888, right? I'm just saying use this variable or this literal, right? That's the syntax. So $ variable : literal. And in this case, that means that if it's on Cloud Foundry, it'll find an environment variable called vcap_services, and then that'll have a JSON blob in it called configuration service, and then inside that there's another JSON attribute called credentials, and then inside that another JSON attribute called URI, and so on. Okay, run. Here we go. We can confirm that is up and running. Localhost 8761. Okay, that's where I've got this thing launched. Oh, there we are. Come on. So this is our Netflix Eureka-based service registry. You'll notice that, of course, we have no registered applications at the moment. We'll fix that now. So let's look at our first actual service. This is going to be a bookmark service. It's just a nonsensically simple service for managing bookmarks. You'll note there's an exception in my Eureka. This is Eureka getting really perturbed that I haven't set up a replica. Okay, and the reason I haven't done that is because no time, and I'm lazy. But it will also give us a big red stinking, like, why, Josh, why letter right here in a little bit, right? And that is because Eureka is sort of the thoroughfare by which all your services discover each other. So it's insane not to have it in a highly available mode, and it's dead simple to do. So heed its caution. Okay. Where's our config service, pom.xml, something like that. Okay. Paste this in here. And bookmark service. Okay. So I'm going to bring in Spring Cloud Starter Eureka and Hystrix and the config client and Spring Boot Web. And I'm just going to build a simple service here that will manage bookmarks. It's just basically for a given user. Here's his set of bookmarks or her set of bookmarks. So a bookmark service, good. Got this, source main Java demo. Okay, and I'll create a bookmark application after I've imported this. Go, go, go. Okay. And voila. So there's my Spring Boot code. It's got a Spring Data repository. It's got a REST endpoint. It's I'm injecting the message and I'm printing it out here. I'm creating some dummy data here. So I'm just when the application starts up, it'll go through this list of names and create a bunch of bookmarks for the user. So I can run the service and then get at the bookmarks for that user by going to /user/bookmarks. I'm going to create a Spring. I'm going to create a spring.application.name here, so it'll be bookmark-service, and again, I'm pointing it to the config server. So all the config for these different services lives in that directory, right? I'm not specifying application.anything for each service now. So it's just one Java class and a bootstrap. And again, the bootstrap is fairly mundane. You could do it in your sleep. Okay, so here we go. Run. I wonder if Eureka is going to show us how angry it is. Look at that, so red and unhappy. I think the emoji would be better. Something. I mean, we know it's unhappy, but something smiling or something. I don't know. Just sad. Okay, so this is up and running, and it'll by the way automatically register itself very soon with the service registry because we have Spring Cloud Starter Eureka. So this will automatically look in the configuration, and it'll discover the configuration over here. cd home, Bootiful, cat bookmark service. So I'm going to cat that, and you'll see that that's the configuration we need. And then we'll see that I've got application.yaml, and application.yaml provides the Eureka client service URL default zone property. And that is going to either dereference this Cloud Foundry environment variable, or it'll give us this literal localhost 8761. So it knows to phone the service registry and register itself. You'll see that here. There it is, bookmark service. It's up and running. At the moment, there's one instance, but were I to start more instances, I'd see them all registered here. I can now go to the bookmark service, hit the info endpoint. If I go to pweb and I go to /bookmarks, I find that there's one bookmark for that user, another one here for JLong, okay, etc. Now, you'll recall that I also had that message in the configuration for this service, right? So bookmark service. There's this message saying "Salut Devox France from bookmark service." Well, that doesn't make any sense. I'm on the VJug. This is exactly the wrong kind of message. This is what you would call a mistake. I don't know about you guys, but sometimes I make mistakes. So I want to change that service, that configuration value. I'm going to go ahead and open up this config file here, and I'm going to say, let's see what I'll say. The bookmark service. Okay. I'm going to save it and then commit it because I'm not scared of commitment here. Okay. Terrible commit log. Don't do that at home. Now, if I were to go back to my config server and refresh, I can see the updated configuration is visible here. But my service itself, right, doesn't see the new string. If you look at the service in my code, my little REST controller here, I've got this REST controller I've injected the message, which I'm getting from that config file, and I've got an endpoint called message. I've also annotated that controller with @refresh_scope. This is plugged into the mechanism in Spring Cloud that lets me refresh application contexts. I can invoke an application context-wide refresh by going curl -d empty bracket, curly bracket, curly bracket. Basically, I'm sending an empty post to that service, and that service, of course, is here. So, okay, /refresh. So what I'm doing is I'm saying send an empty post to the refresh endpoint. The endpoint will, spit out that it's changed one key, and then of course, if I go back here, I can see that message has been changed. This is a very, very valuable facility. It lets me change beans in situ. So I'm saying refresh just this bean. This is very valuable for configuration, but you could also, in theory, for example, apply this to a data source or something else. This is not meant to, you shouldn't put every bean under refresh scope. This is not meant to make it easy to refresh everything. I would put things that you need to be able to switch out dynamically, like, for example, a data source under this scope. For everything else, of course, see our fine friends at Zero Turnaround. And this is more of a production facility, right? This is for, I've got a data source that's gone down. I need to route traffic to a new one. How do I change the configuration? Do that like this, okay? Now, I'm going to add another service here, contact service, very much the same in make and form. So I'm not going to enumerate all the code for numerous reasons, not the least of which is lack of time. Okay. And good. Command J, BM contact service. Okay, got that. I'm going to go back to my Maven build and bring back the contact service into the fold. Here we go. I might as well bring this one in as well since it's unhappy. And we'll bring in dashboard service so shortly. Okay, now that's those. So okay, now I'm going to bring the contact service in. It's going to be very much the same thing. So source main Java demo. Okay, Maven re-import. Going to bring in a contact application. And here we go. Okay, so very much the same thing. It's a REST controller, some data. I'm using the same basic stack as the other one, but the idea is that they could be different, right? They're just two APIs as far as each other is concerned. They happen to share a correlation ID, in this case, the username, right? And in fact, in a more modern system, you just, instead of having usernames as a URI artifact, you might even just have an OAuth token. So even that is kind of redundant. But the whole point is to have services here, not to build the best service I can right now. I'm going to have another bootstrap, so I'll say contact bootstrap, same idea, and run. So that'll start itself up, and we'll see that register itself in a second. Let's move on to the contact service while that's getting going. I'm going to add, this is the one where sort of the rubber meets the road. We're going to integrate our different services here. Source main Java demo. And I'm going to re-import this. Wait, I need to change the POM, it seems. Yes, I need the POM. Just need that one, who cares? So this is our passport service. Okay. And same idea as before, except that we're going to integrate other services. So I've brought in the Spring Cloud config client. I've brought in Hystrix for the circuit breaker pattern, which we'll look at in a second. I brought in Netflix's Feign for declarative REST clients. Again, we'll look at that in a second. I brought in the support for Zool, the micro proxy, again from Netflix. We'll look at that in a second. We've already seen Eureka. I brought in Actuator to register those production endpoints, and I brought in Boot support for building web services, which we've again already seen before. So now I'll bring in outside passport application, and I'm gonna passport Java. Okay, good. So here we go. Here's our very simple little passport application. I will give it this, bootstrap, okay. Run it. And while that's running, let's take a look and make sure that our the service is registered. So there's the contact service. It automatically registered itself. The bookmark service too, right? And when this application starts up, the passport service application, it's going to do a few different things. So let's take a look. First of all, it's a Spring Cloud application. This is a meta annotation in Spring Boot. It means that the application is by definition also a Spring Boot application. We bring in the discovery client support. So again, there's a common abstraction, and the discovery client there's implementations for Zookeeper and Eureka and Console. We'll bring in the circuit breaker support. Okay, so again, this is just common to most microservices or these use cases. That's why there's the Spring Cloud application annotation. There's no reason you couldn't, of course, use each one of those annotations individually. I'm also turning on support for declarative REST clients using Feign, and I'm turning on support for the Zool micro proxy. Other than that, I've printed out a message, very, very common. We've done that before. And we have 3 different beans of type command line runner. Now, command line runner, as I recall, is just a callback interface for Spring, and Spring Boot in particular, that says when the application starts up, give me a reference to the public static void main string arguments array, and let me do startup or initialization work. I've got 3 different command line runners here that will each work with different services in different ways, and we'll see sort of from low level to high level. The first approach is to use the discovery client directly. Here we're saying that we want the discovery client to find all instances of the contact service in the registry and to give us a list back, and then we use the Java 8 Lambda support to enumerate all of those instances. These service instances, this is a common abstraction interface. So here we're saying I want the service ID, the host, the port, etc. And from here, I can do whatever I wanted, right? I'm actually just printing out information about the host and port, but I could look up, I could get the host and port and use that to make a call with some other library. I could get the host and port and do whatever I need to, right? This is if I don't have any other way of making a call, I could actually just make the call directly this way. And of course, I could also using specific mechanisms, mechanisms specific to each service registry, I could ask for metadata about each register service. Like, for example, if I have some sort of leadership election scheme going on with Zookeeper or something like that, I might say that this is the leader, or I can do whatever, right? I can actually get that information from here. For our purposes, it'll be enough to print it out, right? So I'm going to go ahead and run this again, restart, kill. And then I've got the REST template example. So this is using a REST template instance that comes with Spring Cloud. Let me see the first one here. Hello, passport service. There's our message. Scrolling down. Okay. So you can see I've got 2 services for context, one contact service, one bookmark service, and here's the host and port for each. Now, again, if I had 10, I would get 10 service instances back from the call there, and I could choose from among any of those services by whatever criteria, and then delegate or route all my requests to that instance. But since what I'm really trying to do is pick an available instance, I can use client-side load balancing. So Netflix provides something called Ribbon, and Ribbon is a software-defined load balancer. The benefit is that I, as a client, am in the best position to make the decision about which service should handle my call, and to do something if that service isn't available. It's much better to move all of these decisions to the client, especially in mid-tier services. Obviously, if you're talking at the edge, if you have a service at the edge, it's much better to have that behind DNS. But for business decisions, keep that in the client. Again, you can make changes to the code more logically. You can do whatever you need to, right? And Ribbon is easy to use, and we've plugged it in, for example, to the REST template here. And so the REST template in this case is both Eureka and Ribbon aware. When you say http://bookmark-service, that's not a host name. That's not in any DNS entry or anything like that. That's going to the service registry. REST template is there's a listener, there's an interceptor that's going to see the request, it's going to extract the proposed host name, and it's going to replace that with the first available instance of that host or that service as it gets it back from the Ribbon software-defined load balancer. And then I'm going to make a call, and then I'll get a list of bookmarks back. This is, by the way, a implementation of the type token pattern, so very important that you notice that this is actually an anonymous inner class. This helps Java keep at runtime information about its generic arguments for an instance variable, right? It can't do that otherwise, so you need anonymous inner classes. You need a class, basically, for that to be still there. And we can use that generic type information at runtime to ask the REST template to give us a list of bookmarks back. So again, this is a local type, this bookmark. It's in the same code page as the Passport application. It is not the same bookmark that was annotated with JPA annotations back in the bookmark service. And it's nice because the bookmark service could be in some other language, it can be whatever, but I can still get the benefits of talking to other services in terms of strongly typed objects here. This eventually gets done by the HTTP message converter mechanism. And then finally we have the feign example. Okay, so here I've just got two objects, the bookmark client and the contact client. They call these backend services, and these types are just interfaces. They're annotated with @feign client, and again, I've got a reference to the service ID in the service broker here, and I'm saying whenever somebody injects an implementation of this bean, they can make a call against good bookmarks, and that'll be routed to the host and port as discovered by Ribbon through Eureka /user ID /bookmarks, and the user ID is the argument that's been passed here. So very, very type-centric, safe way to call REST services if you like, right? So these are progressively more sophisticated ways to call different services. And you can see that output reflected here, right? So here's my REST template version where I'm calling and I'm getting a list of bookmarks. And then here's the feign example where I'm using the interface. I'm not even writing any HTTP code. I'm just using very, very high-level interfaces and declarations, getting the context back. Now, I've also, you'll recall, set up a micro proxy. I've got Zool. So if I go to my code here, which is where refresh that, go to Passport service. If I go to Passport service, I've got passport /JLong /passport gives me the aggregate of both the bookmarked and the context for this user. That code lives here, right? Let's see. In the Passport REST controller, and I'm saying, okay, call the backend services, the integration client and the bookmark client, and give me the collection of contacts and bookmarks. And I'm doing that through this integration client bean that I just defined, and in that I'm injecting the contact client and bookmark client feign-based REST clients. And I've got two different methods here, one called getContacts and one called getBookmarks. These are annotated with the @hystrix command because what I'm doing here, in effect, is making a shaky, risky, REST service call, and that call may fail. And if that fails, I want it to do the right thing, right? This is an example of the circuit breaker pattern. I'm going to stop failures from cascading and impacting other systems. So if the failure happens and the circuit gets opened, then this method won't be invoked anymore. Instead, the getBookmarks fallback, which in this case just returns an empty array list, will work, right? Netflix does this quite a bit as well. If a service isn't available, they'll do something different, but maybe something helpful. Like if the search isn't available, maybe they'll show you recommendations or something like that. There's a great talk by a guy named Fred George out of the UK, and he talks about this idea that the human body is also a microservice system, right? If you cut your finger and you start bleeding, of course you don't just blue screen, right? I mean, you degrade gracefully. You get a little bit of blood, but the rest of you keeps moving. So this is very much about that sort of effect. So we are letting Spring Cloud automatically wrap these in circuits. Okay, so if I were to take the bookmark service out of commission, I'm going to go to this. I don't know if you can see this in the Hangout, but in IntelliJ here, I've got an exit button. I'm going to hit exit. That'll decommission my bookmark service. If I go to the registry, it's gone. And if I go back here, you'll see I make a request and I get an empty array list instead of actually having an exception, right? So it's doing the right thing. I also have that micro proxy, right? So I showed you that I have @enable Zool proxy, and the benefit of that is I can now say I can actually say that I can route all requests to this service, and they will route to backend services for me. So I can say, for example, contact service /jlong/contacts. And this is ideal, for example, for HTML5 clients that cannot traverse, cannot connect to other hosts and ports. If I had the bookmark service still running, I could also call that one, right? So this is an example of an API gateway. Netflix does this quite a bit. They have, for example, 600 different microservices. Whenever they add a new client, of course, they're not going to add new, they're not going to change every microservice to accommodate that new client. Instead, they stand up a layer, like this one, for example, that routes requests to the backend service directly, like we are doing here, or that adapts, transforms, or enriches it, as we saw earlier. So the one last thing to see here is that we've got these circuits, and I'd like to be able to get insight into what they're doing. And of course, that's a very natural use case. So I'm going to set up a dashboard so I can see all of these circuits in my system and see their behavior, see what they're doing. Okay, Command J, dashboard, here we go. Source main Java demo, dashboard application. Oops, we import that. Okay, dashboard application. 1 second here. Command J, dashboard application, go, go, go. Run. And that, oops, I think I've omitted this, but whatever. Bookmark. There we go. That'll be running on port 57649 because I'm just letting Spring Boot pick one for me at this point. I don't care. Histrix.stream, and I can plug in this little dashboard UI here. I can plug in the host and port for my passport service. And my passport service, of course, is where I have those Histrix circuits. So I'm going to say Histrix stream, hit monitor, and you'll see I've got this kind of live view of the content of the circuits in my application. If I go to my application again, back here, you'll see, okay, JLong passport. If I hit refresh, remember the bookmark service is offline, so I have a circuit that's broken here. It's saying there's errors, right? The contacts are working. I can see if I stop refreshing over here on the right, as I step off the gas, it drains down again, and so on. It's a moving average. So it's a very convenient way to see the errors if you have them in your system. Now, I think that about concludes a look at the high-level code concepts. Always remember, distributed systems are hard. So it doesn't have to be that hard. There's common patterns out there. We're not the only ones talking about this. Spring Cloud is a codification and an embrace of a lot of the design patterns that have come from these large organizations that have had to make the move to the web. You're not alone. I'm not asking you to bet on a theory here. This is what organizations have had to do. Things have changed in the last 10, 15 years, so why would you still build applications that looked like they did 10, 15 years ago, right? Remember, the cloud is important here. Netflix talked about deploying containers. I've been using jars in this, for example. It's very simple. It's very natural to wrap that in Docker and then deploy that. From our perspective at Pivotal, we have an open source platform as a service called Cloud Foundry. CloudFoundry.next is Docker native, and in fact, you can try some of those bits out right now in a distributed runtime called Lattice. Remember, treat servers as cattle, not pets. So if a server goes down, just destroy it and create a new one. As I said over and over, this is a cultural change, not just a technology change. If you move your systems, if you move your services into small, singly focused business verticals, you can then move faster, not just in your code, but in business as well. I hope you'll remember that scale is everybody's problem. Spring Cloud hopes to, we endeavor to bring solutions for these kinds of architectures. We endeavor to simplify the patterns designed for these architectures. A cloud is a big part of that. Agility is a big part of this, so definitely keep that in mind. You notice that I didn't use a cloud at all for anything I've shown you here. But again, if you're trying to manage this stuff, you're trying to keep this all up and running, it's very important to have a consistent approach. So if that's DevOps, that's one thing, but much more naturally, something like Docker, something that a distributed runtime that can run Docker is very, very important here. If you want to know more about Spring Boot, don't hesitate to check out, of course, the VJUG appearance I did this time around this time last year, actually. So thanks again, Simon and team. Our blog at spring.io/blog, lots of stuff there, but of course the Netflix technology blog. My pal Chris Richardson has a great design patterns write-up website called Microservices.io. Fred George's talk, I mentioned that. My pal Matt Stein has a good talk on Cloud Foundry and microservices, sort of more of the motivation if you didn't get any of that from here. And with that, I am Josh Long. Thank you for listening. It's been an honor to talk to you. I know we've covered a lot, so again, if you have more questions than when you started, you have my email there, my Twitter handle. Let me, I'd be happy to try and sort it out for you. And thank you. Any questions there, Simon?
Awesome. Thanks very much, Josh, for a really entertaining session. Yeah, we've got a bunch of questions. So let's start with one from Andreas Evers on IRC.
Hi.
And Andreas asks, let's go to his first question. As the microservice becomes dependent on the config server, does that create a resiliency issue when no microservice can start up after a global crash until the config server is up?
Well, you do need to have some things up as much as possible. Obviously, if you have a microservice and it doesn't talk to anything in the world, then of course that's what is that, dev random? I mean, you've got nothing, right? So you're gonna have a dependency. It is very easy to make the config server highly available, so I wouldn't worry about it too much. In the worst case, all you're doing is using the configuration mechanism that Spring provides, and of course, you could just as easily move those config files into your application or put them adjacent to your application. Instead of having source main resources application.properties or application.yaml, put the file next to the jar or next to it, and then you can strip out the config server if for some reason you really truly can't get the config server up and running again. But again, it's very easy to make that highly available. Just add more nodes, so that shouldn't be a problem. And then I would stick its resolution behind DNS. That's one of those things where you do want to have that, just a well-known place, just like Eureka, or an environment variable in this case.
Okay, cool. Another question from KR1S. How do you share common data structures among your services, or how does the bookmark service publish bookmark class to all its clients?
Right. So if you're working in a homogeneous system and all of your services are written in Java and so on, there's no reason you couldn't export those types as a jar. A lot of distributed systems these days don't use jars directly. Maybe they'll use type contracts or type definitions through something like Google protocol buffers. Spring Framework natively supports that, for example. I put up a blog just a few weeks ago, actually, on spring.io / I forget, but it's on Google protocol buffers, and then my name, and you'll find it in Google. And that gives you the benefit of backwards and forwards compatibility, because these definitions are, as long as you don't change any of the existing properties, as long as you just add, then there's no reason that a client from generation X couldn't use a definition from generation Y. So that's a one way to maintain, to be a little bit more resilient to changes between these types. But if you end up having all this different clients depending on the same types between versions, again, you're going to eventually run into a synchronization problem if you end up changing a lot of things. So it's important to remember that you're trying to find a bounded context here. You're trying to define services that are small enough where you don't have lots of other objects from other domains in your service. Indeed, as much as possible, I try and keep those references to other services down to an ID or a correlation ID or something like that, right? If you think about Amazon's API, they have the online web application, which is the shopping cart and product reviews and so on. And there's products and fulfillment and there's shipping and all that. It may look like one giant ERD diagram, but really not so much, right? From the fulfillment perspective, they may care about the online shopping cart domain, but their business, their world is all about sending products down and via the mail and so on, and getting them delivered via drone, perhaps. And so what shopping cart or whatever it was when they were on the website, that's maybe at best a correlation ID. They don't need the whole object graph for that. That's a service lookup later if they need it. So try and keep those things singly focused, right? Okay. Bounded context, very, very, very domain-driven design concept.
Okay, cool. So we'll take one more because I know you've got a buff starting
No,
shortly.
I'm at your service. I can be late for.
Okay. So another question from Andres.
Hi.
Wouldn't it be possible to combine the ease of use of Feign with the hypermedia support of Spring Hate OS?
Sure. So you can Spring HatOS is the library that provides the ability to, on top of Spring MVC, to describe envelopes, which themselves have links and payloads, very much like a link rel tag instead of HTML for referencing a CSS. Yeah, you can use a resource type. Just again, Feign is using Spring's message conversion, right? And so if you have JSON, for example, it'll try and return types that it can cast to. So if you give it a resource, if you say Feign collection of resource of foo, then sure, why not? Is that your question?
Yeah, I think so. I think that sounded good. Couple of questions from Haytham, and I think Oleg has already perhaps got the answer that you're going to say, but I'll ask it anyway. After you're using addressing a service, I guess, or in a Docker container, what's your recommendation for cloud deployment? Which PaaS or service would you use? Would you recommend AWS?
AWS is one option, sure. So obviously I work for Pivotal. We have an open source platform as a service called Cloud Foundry. I would actually let me preface this by saying I actually have my own account and I pay for it. So I'm an employee, but I like it a lot and I actually use it for personal things. Cloud Foundry is a open source platform as a service. It's used by, I mean, everybody. It's IBM and HP have built their cloud offerings based on top of this, so you have the ability to move from one platform to another without worry. It's the same API. It's used by Baidu, for example, for billions of page views every day. Baidu is the Chinese Google, if you will, search engine. It's huge. It supports Heroku build pack, so it's easy to plug in. And we've teased out the bits that support the distributed runtime bits, the things that support things like scheduling and distribution of work. We've teased that out into a separate project called Lattice, which is also open source. You can download that now, and it's small. It's all written in Go. It's blazing fast. You can run it on a laptop. In fact, there's a version that'll run with Vagrant up, so you can deploy Docker images to that, and then say scale, and then deploy, and it'll give you routes and everything. So I would check that out. That's definitely where we're excited and what we're investigating. And you can run Cloud Foundry, of course, and Lattice on top of AWS if you like. In fact, our own hosted version of Cloud Foundry runs on AWS. So it's on run.pivotal.io if you want to try it out there. Or you can buy a shrink-wrapped version for all the money, all of it, called Pivotal Cloud Foundry if you want, or use the open source. It's all good.
Awesome. One last question from Andres. Will there be more of the Netflix OSS libraries or projects wrapped in the Spring Cloud ecosystem?
Yeah, and in fact, there are even more than I've managed to talk about here. But yeah, of course. And if you have something you'd like to see, please. We just released 1.0 for Spring Cloud, 1.0 GA. It's out now, but we're already working on 1.1, and some of the changes we're looking at are better integration with messaging, and then because of course Spring and Spring integration are messaging centric as well, but more along the lines of CQRS kind of support, and we're fleshing out the service registration story. So we have GA quality support for console, for example. And yeah, please, we're always interested in ideas. Anything that has a good use case and that would help. We're happy to hear about it, and pull requests are of course even more welcome. So github.com/spring-cloud. Don't hesitate to check that out.
Awesome, and I guess with any further requests for those kind of things, they can also contact you at Starbucksman as well. So
please do. I'm very happy to carry the discussion online.
Awesome. Well, with that, Josh, actually, if you wouldn't mind unsharing your screen just so we can see you again.
Oh.
Sorry, I should have asked that some time ago.
Where am I? Did I?
So yeah, with that, I'll just say thanks everyone for all the questions on IRC. Thanks for watching, and of course, massive thanks to Josh as well for your second session.
Thank you.
This time from another continent, so we'll maybe try and get you in a third. Maybe, who knows? Maybe Devox in Morocco or somewhere like that. We can do a third continent.
Or UK. I'll see you there too.
Or UK, absolutely, in a couple of months. So yeah, with that, thanks very much for everyone. And Josh, if you was to hang on, I'll stop the broadcast. If you was to hang on, we can do an interview straight after, which will be available on the VJug podcast hopefully tomorrow. If not, it'll be over the weekend.
Thank you very much for having me, and thanks for your time, everybody.
No problem. Thanks, everyone.
Cheers.
Bye.